Yeah, so let us start the session. Good evening, everyone. Am I audible? Please let me know in the chat box. Yes, so let us start the session. Yeah. How was the test yesterday? So everyone has written the test. Fine. Okay. So let's discuss the answers related to that particular test. Okay. In this session, let's discuss the answers related to this particular test. Let me share my screen. So, what was the answer for this particular question, guys? Which of the following is one's complement representation of minus 34? It's a very simple question. What is the answer for this? Take your time and please let me know. Okay, I got one answer C. What about others? What is the one's complement representation of minus 34? Others also, you can take your time and please try it out. One's complement representation of minus 34. Okay, I got two answers. Yeah. So what is the process? What you're following for performing this particular thing? You can also unmute your mic if you want. Exactly. So you're going to just invert the bits, right? So 34 is nothing but it's 00100010. Okay. And if you're going to invert it, it is option C, 110 11101. Am I right? Okay. Yeah. So it's option C. And obviously it's not option B because your MSB is 0, right? So it's a positive number. Okay. For in your ones complement representation, your MSB is basically 1. Okay. Yes. Exactly. Now, what is the second question answer? So a computer has a word length of 8 bits, including sign bit. It required to determine the range of integers that can be stored in the computer. So if 2's complement is used to represent the negative numbers, then the range of the numbers is. It's a very simple question, which we have already discussed. Think about it and answer. Using a 2's complement format of representation. What is the range, guys? What is the range of values which we can represent using 2's complement format of representation? So in the previous session only we have discussed this. So which is nothing but minus 2 power n minus 1 2 plus 2 power n minus 1 minus 1. So n is equal to 8. So if my n is equal to 8, which is nothing but minus 2 power 7 2 plus 2 power 7 minus 1. What is 2 power 7? It's option number D. Yeah, exactly. So it's minus 128 to plus 127. Okay. Yes. Next, so the range of signed decimal numbers that can be represented by 6-bit ones complement format. This is also a very straightforward question. Whether it is option A or whether it is option D or C or B. Exactly. It's option A. So the range of ones complement format of representation we have already discussed. It is minus 2 power n minus 1 minus 1 2 plus 2 power n minus 1 minus 1. Okay. So if anyone haven't watched the previous session recordings, if you want, you can watch it out. Okay, which is already available on our channel. Now, Next, a signed integer has been stored in a in a byte using two's complement format. We wish to store the same integer in a 16-bit format. We should copy the original byte to the less significant byte of the word and fill the more significant byte with 0, 1 equal to MSB of the original byte, complement of the MSB of the original byte. What is the answer for this? Option C. Okay, I'm getting few responses. What about others? What do you think? Should we fill it with 0 or should we fill it with 1, or it is equal to MSB of the original byte, or is it equal to complement of the MSB of the original byte? So the question over here is signed integer has been stored in a byte using two's complement format. So we wish to store the same integer in a 16-bit format. Yeah, anyone who is there who is not clear about this particular question? Anyone wants me to explain this particular question? Okay, so let me briefly explain for someone who is not able to understand this. So let's say if you have already represented a signed number using 8 bits, and definitely for positive numbers you are going to have sign as 0, and for negative numbers you are going to have 1, even if you are representing in 2's complement format. That we have already seen the pattern. Now, if you are going to extend it to 16 number of bits, then you should perform sign extension and you're going to copy whatever the MSB which is present. If the MSB previously it was 0, you should fill with zeros, or if MSB is equal to 1 previously, you should fill with ones. Okay. So the answer over here is exactly sign bit extension. So the answer over here is equal to the MSB of the original byte. Okay. Yeah. Next, this question was many people were having queries about this particular question. Minimum decimal equivalent of the number 11C point 0 is. What is the answer, guys? You're getting option B. Okay, the minimum decimal equivalent number 11C of the number 11C is 194. Okay, option B. And what about others? 195. Oh, okay, but it is not present in the option now. Others, like what are the different answers you are getting for this particular question? Assuming base is equal to 13. Yeah, my next question is that only. What is the base you have considered over here? I haven't mentioned any base over here. I haven't mentioned any base 16. How many of you have assumed the base is 16 over here? 1 to the base 16? Yeah. So if you consider base 16, your answer will be what is your answer? You're going to get 284, but that is not present in your option, right? So over here, the question over here is the minimum decimal equivalent. Okay. If we want to get the minimum decimal equivalent, we can also consider the minimal base. Okay. So what is the minimum base we can consider over here for this particular number? What is the minimum base? Exactly. We can consider the minimum base is equal to 13, because if we consider the minimum base to be 13, then the digits in this particular base 13 will be from 0 to 12. Okay, which is nothing but C. Okay, so that's the reason I'm going to consider my minimum base to be 13, because the maximum value of the digit present over here is C. Okay, so the base over for this particular is 13. Okay. Now, what is that we are going to get? 12 into 13 power 0. What happened to this? 1 second. So it is 12 into 13 power 0 plus 12 into 13 power 1. Sorry, plus 1 into 13 power 1 plus 1 into 13 power 2. That is what we are going to get now. Yeah, 1 into 13 power 2. Yeah, what is the answer we are going to get? It is 13 into 3. I have calculator open. 13 into 13, which is 169, plus 13 plus it is 12, which is 194. Option B. Okay. Is it clear how we are going to solve this question? It's 13 square. Is it clear for everyone how we are solving this question? Anyone having any queries in this? Shall we move forward? Now, what is the answer for this question? If a base B number system 54 by 4 is equal to 13, the base of the number is. Take your time and try to answer this. Option B. Okay. Base 8 you are getting up. Okay. Option B. Okay. So 54 by 4 is equal to 13. The base of the number they are asking, and they are considering the base of bases to be B. Okay. Okay. What is the process we are going to follow for this particular kind of questions? What is the process we are going to follow? How to find an unknown base? What is the process? Okay. Exactly. You need to convert both sides into decimal. Then you are going to get your answer, right? So 54 by 4, which is equal to 13 base B. So you can basically convert it into decimal, which is nothing but 5B plus 4 into B power 0 is 4 divided by 4 into B power 0 is 4 again, which is equal to B plus 3 into B power 0, which is nothing but 3. So which is nothing but 5B plus 4 is equal to 3 plus B plus 4. Okay. So which is nothing but 5B plus uh, so 4 will get cancelled. 5B plus, which is basically equal to 4B. What I'm getting? Am I missing something over here? Okay, sorry, it's 12, right? So 4B is equal to 12 and B is equal to 3. I'm getting base to be 3. Is it correct? Okay, it's not present in the answer. I think I have made some calculation mistake. So 5B plus 4, which is equal to 4B plus 12, and which will become B is equal to 8. Yeah, we are getting B is equal to 8. It's option B. Everyone getting the same thing? Yeah, I can see the answers, which is B. Yes. Now, next question. I think this is straightforward. 10110 base 2 is numerically equal to, you can manually convert it into 27 base 16 and you can basically cross verify your answers. So what is the answer you're going to get for this particular question? 100 base 2 is numerically equivalent. Option D. Yes, exactly. Correct. 212 to the base 4 is the correct option. Yes. Now let's a computer has following negative numbers stored in binary format as shown. The wrongly stored binary number is minus 37, minus 89, minus 48, minus 32. Again, the same thing. You can basically apply one's complement on this binary numbers and you can cross verify with whatever the decimal equivalent you are getting. So you can just complement them and you can check it in decimal format and you will come to know. So what is the particular wrong value? Option C. Okay. So you can basically convert this 1110, 1300. You can perform one's complement on this, which is nothing but 1110 and 1000. If you perform ones complement on it, it is nothing but 0001 0111. Okay. And if you can convert it into decimal, you will get to know whether it is a correct one or not. Okay. Yes. Next. Next, what is the question? Is it clear? Sorry. Yeah. So basically, it is stored in two's complement. You're going to perform two's complement and you're going to cross by. Yeah. Now, next, the number of 1 in 8-bit representation of minus 127 in two's complement form is m, and that in one's complement form is n. So, what is the value of m is to n? Yeah, this is also a good question. Yeah, how you are going to get? So, what is minus 127 in two's complement format? So, once you can check what is plus 127, which is basically 0 followed by all ones, and it is represented in 8-bit format. So, in plus 127 is nothing but 0 followed by all ones. And if you are going to perform ones complement on it, then you will have only one. Okay. So plus 127 is nothing but 0 followed by 1, 2, 3, 1, 2, 3, 4. Okay. So if you apply ones complement on it, it is nothing but 1 followed by 000, 1, 2, 3, 4. Okay. And if you represent the same number in two's complement, it is nothing but it is 1 followed by 0. So if you apply two's complement on this number, it is 1, 0, 0, 0, 0, 0, 0, 1. So in two's complement, you have two number of ones, and in one's complement, you have only one number of one. So this is m and this is n. I think this is what given in the question, right? So the number of representation in two's complement form is m. Okay, this is m, which is given in the question, and this is n. So m is to n is basically 2 is to 1. So basically, they are asking the number of ones in two's complement format of representation is ratio to the number of ones in the ones complement format of representation. That is nothing but my 2 is to 1. Exactly. Yeah, m is equal to 2 and n is equal to 1. Exactly. Yes. And which of the following is the two's complement form of minus 68? This is also a straightforward question. So you can discard the first two options because MSB is 0, and you can basically check with B and D. What is the correct answer you are going to get for this between B and D? B. Okay. So first of all, you can write down the original value of 68, and then you can perform two's complement of 68. Okay. So 68 original value is basically 0100000100, which if you can perform the two's complement, you are going to get this particular value, which is B, which is B. Yeah. If I join group yesterday, so if you could please tell me about the program and how it's going. Yeah, sure. I will let you know. Okay. So before that, how are the questions? Are they easy only, right? So tomorrow also we are going to have a similar kind of test. Most probably. Okay. Let's first of all complete few topics like BCD code, accessory code, and gray code. And after that, we will also we will have a similar kind of test. Right. Pranab, if possible, can you watch the previous two session recordings? I will also share the recordings links. So once you can go through like what is the process, what are we following, and what is the kind of sessions we are going to have, and what are the models we are going to have. And we are going to have this kind of test. I will be sharing Google Form link, and you will be having some time limit. And you can take your time, and you can basically answer those particular questions. And that's it. This is a format we are going to have. So like if today we are discussing about ones and twos complement format of theory, then we are going to have this kind of test so that you can basically evaluate whether how much you have understood about that, and you can basically come to know like where are you exactly lacking in. Okay. No, it's not kind of certification or something. It's just purely for knowledge transfer. That's it. Yes. So that's about this particular session. And in next session, we will start with the different. Okay, we do have some ones complement and twos complement addition and subtraction. And after that, we will see GRE and BCD code of encoding, and let's have a similar kind of test. Okay. Yes. So that's about this session. Thank you. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss, or else we can wrap up this session. Okay. Thank you.